Hello there everybody, it's Mike and I'm here with day 23 solutions video. Just to let everybody know we're going to do things a little bit differently. We're going to be talking more about fractions, we're going to be talking about decimals, and we're going to talk about percent. And those arrows show going in between. So how do I go from here to here, and back? That's really the 10 question quiz is going to pivot to that and change. So let's explain what's going on with all the questions. First up, question 1. Question 1, 2, and 3 are all the same. So I should say 1, 2, and 3. The reason why we're doing this is we're going to convert from fractions to decimals, which I'll abbreviate as DEC, to percent. Now, how do we do that? Well, what's a fraction? A fraction is a numerator and a denominator. There's a top and a bottom, and it basically says this is how many sections are cut, and then this is actually how many sections we want. So what does that mean? This means I can make as many cuts as are here, but really I'm only talking about one section of all the cuts that I made. So in this case, I turn this into 4 pieces. I've made essentially 4 sections that I've cut this into. And then I'm talking about one of those sections. So on a pizza, if you divide it into 4, you took one of those, that would be 1/4 of the pizza. So that's just to go over fractions, that it's a part of the whole. We've got a whole pizza here. We just put it into 4 pieces, and we're talking about one of those pieces specifically. Let's talk about decimals now. So decimals are on your calculator. They can be expressed like that, or 38.888, or they can be 100.00001. Those are all decimals. What do these all have in common? This decimal point. That decimal point shows numbers that are 1 or bigger versus smaller than 1. So on this side we got really small, and on this side we got really large. And as numbers or these digits keep moving farther away, we get smaller and smaller and smaller. So if I did this, this is really small. The way that I would read that is this is tens, this is hundredths, this is thousandths, this is 10,000ths, this is going to be 100,000th, this is going to be a millionth, this is going to be a 10 millionth, this is going to be 100 millionth, and this is going to be 1 billionth. So it's like if I took this whole thing and then cut it up into 1 billion pieces, I'd be talking about one of those infinitesimally small pieces. So things get smaller as you move this side, things get bigger as you move to this. Obviously the same, if I gave you that much money, you'd have 100,100 with some tiny billionth of a cent that didn't really matter. So that's what a decimal is. A decimal shows the numbers that are bigger than 1 and the numbers that are smaller than 1. And then percentages. Percentage is just connected to decimal. And because humans really like numbers that are around 100, or we like 10, we love those numbers. So to see like this, that's kind of freaks humans out. So we don't like those kinds of numbers. So we turn it into what's called a percentage, and we just multiply it by 100. So 8.6%. We could also say 8.65 because I wrote it there. So these two numbers are identical. They're the same. So really think about that for a second. We got 0.0865 is the same thing as 8.65%. And you'll notice that this decimal moved once and twice over. It's kind of like those exercises that we're doing, timesing by 100. So that is percent. So we're going to convert between all of these. Now the conversions of decimals to percentages, really easy. Fractions, a little bit harder, but there's some tricks here. So first things first, we're going to start with a fraction of 1/4. And we gave these little arrows and we give a blank because we want to fill that in. So how do we go from a fraction to a decimal? Well, this fraction can be converted also on your calculator. So option A is the calculator method. If you punch in 1, then divide, then 4, it's going to spit out 0. Here, I'll write it down here. It's going to spit out 0.25. So your calculator is really good at decimals, right? Your calculator speaks a decimal language. So we could put that in there for 0.25 for the decimal. Now the second way, and you need to know both of these ways because you might not have your calculator, is going to be to scale this up to a number that is something over 100. So how do we do that? Well, we know that 1/4, if I multiply the top and bottom by the same number, it actually stays the same. So 1/4 is the same thing as 2/8. And then what happens if I multiply this, let's say, instead, and we can get the bottom up to 100. What if I multiply this by 10? Well, then I'd have 10 over 40. Okay, well, I'm getting closer there. So what if I tried by 25? Timesing by 25. Well, that's going to be 25 on the top. And what's 4 times 25? That's 100. So this, when we convert, that top number is the same thing as the decimal. So we're looking for that top number, and then we're going to go 0. Whatever that top number is. So that's two ways to do the decimal conversion. And then, in terms of the percentage, when I show you what the percentage is, you're going to get it real quick. So the percentage here is just this decimal times 100. What's times by 100? Move the decimal point twice. 25%. So these three amounts are the same. And that's why we're giving these to you. We're going to start with one end, we're going to go to the other, or we're going to give you a fraction and move. So let's go to question 2 here. We don't know this first thing, but we're given a decimal of 0.1. So 0.1, let's go to this side first because that's actually the easiest. So we just multiply this by 100. So move the decimal point once, move it again. That leaves me with 10. 10% is the same thing as 0.1. Now, once we got that percentage, you might have noticed in the last question that the fraction is actually taking this number, and 10%, if we put 10 over 100, that is now the fraction. So you take the percentage, put it over 100, and that becomes our fraction. So 10 over 100 is the fraction there. You can reduce that as well if you want. You can look up reducing fractions. But as long as you're getting that first idea, then I think that's the most important piece there. So 10 over 100. Now the third one we've got is 50%. So we don't know the decimal or the fraction. So let's do the decimal first. We divide by 100. Move the decimal point over. 0.5. See how this number is like a bigger version of this number? This number is a smaller version of this. We started with 50, we went to 0.5. Now, how do we get over to fractions? We take this number, we put it over 100, and we put that over here. So 50 over 100. So that's how to convert between these three ideas. The numbers are going to change, but the concepts are still the same, and I hope that helps. So let's look at the next question there. So question 4. I'm just going to hold this up here. So Jordy played Halo ODST for 3 of the 24 hours on Saturday. What fraction of hours did he play? Okay, so we got a few things here. We got 3 hours is how much he played. We got 24 hours in a day. And the question is what fraction? So we're going to end up with like something over something, right? That's where we're driving to. So the fraction that we're talking about is 3 hours. This is the amount of time. So we know that's going to be on top. And then what do we do at the bottom? How many pieces did we cut the day into? Well, we cut it into 24, and we're talking about 3 of the 24. So we put the 24 down here, and that is the fraction of hours that Jordy played. So if you wanted to convert this to a similar fraction, you could divide that side by 3, divide this side by 3, and get 1 over 8. Don't worry too much about that, but 3 over 24 or 1 over 8 works just fine. So that's question 4. Let's move on to question 5 here. So, question 5. We got LeBron shot a field goal percentage of 0.650. Now, kind of ironically, that's a decimal point and that's a percentage, but this is actually how that stat is given. So clearly NBA statisticians aren't mathematicians, but that's fine. We'll forgive them. If he shot 100 times, how many did he make? How many shots did he make? So we got this field goal percentage at 0.650. Well, this isn't really a percentage. So let's just kind of take that out of there. Field goals, and this is a decimal. Then if he shot 100 times, so 100 shots. Well, basically, the way that we set this up is we have a number of shots made over top of the total number of shots, over 100 shots, is going to give us 0.650. So how do we do this? Well, all we have to do is then take this bottom and multiply it. So if we multiply by 100 here, that actually cancels that out with the bottom, but we have to multiply by 100 up here. And so the number made, which we're looking for, is this times 100, which is 65. So LeBron made 65 shots in this idea. All right, question 6. Question 6 is our standard kind of decimal question. So when you're dealing in decimals, you want to line up the decimal point. And this is really, really important. So we give two numbers here. We got 2.065. And then we got another thing. So you could do this on your calculator, but we need you to understand that those decimal points and their placing are really important. So when we add these two, you can just go through and add 690.2. Those decimal points and their placement and how that carries through is extremely important. You can't move that. You can't shift those around just to however you want. You need to line up those decimal points, and then it carries through into the answer. So in this one, we got 2.096. These are going to get harder, so you definitely need to practice there. Okay, moving on to question 7. Question 7. This is the standard one that we've had before. 88.8 times 10. 88.8 divide 10. Well, this one makes it bigger. How does it do that? It moves the decimal point the number of zeros that are there. 1 0. 1 0 means one decimal point move. So this is 888. Now divide means move it the other way. And how far do we move it? Well, there's only 1 0. So we move it once this way. And so we have 8.88. So those are the two answers there. You've seen these questions before. You're moving the decimal point based on the number of zeros. So if it was 100, you move it twice. If it was 1,000, you move it 3 times. So that's the number 7 answer. Number 8. For number 8, we've got a picture. And we've got a picture, and we divided this into how many sections. You always want to count. So you can either do that 1, 2, 3 times 1, 2, 3, 4, which I know 3 times 4 equals 12. Or I can just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. We know there are 12 sections. And the question is, when I color in this many sections, what fraction of all of the tiles are shaded? To me, if there's 12 total tiles, that's the number of cuts. That's the number of pieces something is broken into. So we've got the 3 tiles over top of the 12. So there are 3 tiles that we're looking at over 12, and that is our fraction. That's question 8. Question 9. Question 9 is the same ones that we've been looking at. We're going to take percentages of, so 5% of 300. Now I was chatting with John today, and he actually pointed out there's 2 different methods. So the one that you know is to take 10% of 300, which equals moving that decimal point once, 30. So wait, how did I do that? I actually took 10% of 300, means there's a decimal point there and it moves over once. That's 10%. So 30.00, 30 bucks, however you want to state it there. Then I half everything. So 5% is the same as half of 10. So if I halved 10 to get 5, I half 30 to get 15. And so 5% is 15. Now there's another way that I can do this. I can actually go down to 1%, and we haven't gone through this yet. 1% of 300 bucks. Well, that actually moves the decimal point twice. So see how 10% moved it once? 1% moves it twice. So 1% is $3. Now, what do we need to do here to get back to half? Well, we have to times by 5. So if I times by 5 to get 5%, then I times by 3 to get 15%, or $15. Same answer, different methods. In this one you scale down to 10 and then halved it. In this one you scale down to 1% and then multiplied it by 5 to get 5%. Both of those things work. Two different methods to the same right answer. And let's go into question 10. So for question 10, we're going to do fraction questions. And now I just want to review for plus and minus, and then for times and divide. For plus and minus, the denominators need to be the same. The bottom number needs to be the same. So let's write this down. So 1/2 plus 3/4. I can't do this until the denominators are the same. And how do I do that? I need to scale this one up. I scale up the top and the bottom, and this number suddenly becomes 2/4 plus 3/4. Well, that equals, only the top numbers get added, 5/. Bottom numbers stay the same. Stay the same when you're adding. Same thing if you were subtracting, the bottom number stays the same. Now in multiplication and division is just like a special kind of multiplication. So let's do that first. So if I had 1/2 divide 3/4, that would be exactly the same as me writing 1/2 times 4/3. I flip the bottom and top. That's the only trick. Just flip it. Flip and then multiply. So that's 1 times 4. 2 times 3 is 6. 4/6 is the same thing as 1/2 divide 3/4. And again, if this was turned to multiply, then you just multiply straight across and it's super easy. In this case of division, it's 4/6. So remember multiplication, division, and then addition and subtraction. You need to know all of them with fractions. Multiplication straight across. Addition, only the tops do their thing once the bottoms are the same. So that's all the answers for the 10 question quizzes moving forward for the next week or so. Hope that helps. Thanks very much.